All right. Well, welcome everybody to our Let's Code with the Root Robot workshop. My name is Mackenzie Meixner. I lead our customer success team at Sam Labs. Florencia, I've gotten the privilege of working with you over the years. Hi, Carrie. I have not met with you yet, but oh, okay. Carrie and Jill. Awesome. And you're from Jersey, right? In Illinois? I just looked up in our system. Awesome. Well, welcome. I'm based in Chicago, so I'm not too far from y'all. Um, and very quickly before we hop into the Root Robot workshop, I wanted to just briefly, and we're doing this at the beginning of every Root workshop so that you know your customer success managers. You all have been working with Alyssa for some time now. So this is her email. This is her meeting link. If you need anything throughout the school year, please do not hesitate to reach out. But this is the rest of our team. If you've joined any of our other workshops, you might have met some of the other CS customer success managers at Sam Labs, but it's always good to see everyone because if you hop in our office hours throughout the school year, we kind of have those on a rotating basis, so you might meet with anyone in those cases. So, to kick things off this evening, this session is going to be all about our new integration with Sam Root and the Root Robot product line. Um, Florencia, Carrie, and Jill, do you all have root robots? No. Okay. I wasn't sure if Jersey. Okay. Um, so no problem at all. We're going to be going through the platform, and I don't know if you've played around with it yet, but there is a simulator of the root robot in the platform. And so the simulator is pretty neat. Like you can see the little robot and you can code it to do all of the things it would do in real life. Um, Okay, awesome, Carrie. And then obviously after this session, if you stay to the end and complete our survey, you're going to get one. So you're going to get to use it once we ship that out at the beginning of October. So very quickly to kick things off, I wanted to just start with a question about integrating the arts, right? At Sam Labs, we're really passionate about it being STEAM, right? And the arts, whether that's the language arts, whether that's like the physical and like drawing or different creativity pieces to STEAM education. We really think it's critical in supporting students with the critical thinking skills and flexing those skills. So I wanted to start out with this, how are you integrating the arts into your STEAM classes and your STEAM instruction? You can feel free to drop it in the chat or unmute yourself. Awesome. Thanks, Carrie. So using songs or chants to learn math concepts, absolutely. Painting portraits, yeah, lots of SEL connections there. Some of the Sam Labs lessons, which I know you all do, obviously also focus on the arts, right? So like the compose a song lesson, there's the sound player block, but there's also the notes block and the sequencer block in the Sam Space coding platform that allows students to really compose a song or a tune. Um, Obviously, like with the LED lights, we've seen different creative light displays using Sam Labs. So a lot of our lessons in the Sam Labs product line, if you all are using that, integrate the arts. But other things like I know a lot of teachers use a lot of maker materials and just allowing kids the time to actually prototype um, in kind of an unplugged manner is also STEAM and critical thinking, but they're using the arts. Thanks, Florencia. We learned math and science so students can create paintings or drawings explaining their models or their understandings. Yeah, exactly. And I think, the purpose is how all of those skills fit together and allowing kids the opportunities to, do something creative and to integrate the arts in every STEM lesson. because it will reach different learners, right? Everybody has their strengths. So the reason why I'm focusing on this is that when it comes to STEAM and the arts, the Root Robot, we are extremely excited about bringing this product line into Sam Labs and into our Sam Labs family because we feel it really does perfectly align to that STEAM vision. And do I dare say, even does a more fantastic job than some of the Sam Labs lessons in the art aspect of the learning. So let's go through kind of high level how Sam Labs works, and then we're going to go through some code alongs together with some stations where we're going to actually get to make the root robot draw a shape. We're going to actually code a tune for Twinkle Twinkle Little Star with our root robot. And then we're going to have a little dance off code with our root robots dancing off versus one another. And all of this, again, can be done with the physical root robots if you have them, but it can also be done with the simulation and Sam Root that is now live in Sam Studio. So how does it work? Similar to Sam Labs and the Sam Labs product line, the Root robot relies on three pillars. So the hardware itself, the Root robot, there are two versions. There's what we call a Root Pro and a Root Lite. After this workshop, you all will be receiving the Root Lite. That's pictured up here in the top left. And the Root Pro is down here, and that's actually the one that I'm holding. Basically, the Root Pro has a magnet, so it can stick to a whiteboard, where the Root Lite is just used on the desk for the students. So that's the main difference between them. And all of the content, all of the coding can be done with either robot as far as functionality goes. So those are, they might look very similar to a Roomba. And this was actually designed and owned by iRobot as their educational branch before Sam Labs acquired it back in January of 2025. So that's a little bit of the history of it. And that's why I actually got stopped in the airport and they were like, what is that, a Roomba? And I was like, no, but basically like the education side of it. So if the kids notice that too, that's exactly what it is. Alongside the hardware, there is a full coding platform. It's now called Sam Root. And within the coding platform, there are three levels of coding. So again, very similar to Sam Labs. We're going to go through those levels today. And the idea is, you can use it on a web-based browser. You can download the app itself if you have a tablet or an iPad. But students are able to code the physical robot or the simulation to come to life. And then the last pillar are the resources and the content. So the Root product line has its own content library currently with different curriculum and courses that are aligned to national standards. So CSTA, Common Core Math, and ISTE standards. And so with the Root content, it's pretty robust and it's very focused on teaching students to code, but through some of those core subjects like math and like science. As far as powerful tools and the impact and really where this fits into the learning experiences, thinking about thinking, metacognition, and the higher order thinking skills that the Root Robot allows is really evident in the classroom when students are going and using the Root robots. SEL, there's actually a whole SEL section in the Root platform. I'll show you when we get in there. It does a really fantastic job of just kind of integrating some little activities in SEL team bonding or collaboration and communication skills with students. And then lastly, the physical learning, right? The engagement, the kinesthetic side of the Root robot and being able to see it in real life, that the code that they're actually building is controlling that real piece of technology. Now, let's briefly talk about the levels of the Sam Root platform here. So level 1 is what we call graphical blocks. As you can see here, it's very similar to Sam Space in that it's picture-based. It's low text. You're actually dragging and dropping these different images to connect the code for the Root robot. In level 2, it's block-based coding, similar to Sam Blockly. And again, it's kind of the instructions and the algorithm that you're building step by step to code the root robot. And then in level 3, it is script-based coding, specifically Python for SAM root. So in SAM script, we have Python and JavaScript. So that's kind of the difference between the SAM labs and root. But in the root platform, students can convert between all of these levels, which I think is a pretty special feature. So without further ado, before I hop in to the platform, I did want to show you just a little bit of an overview. Since you're all joining with a simulator, it doesn't actually show you what all of the parts are of the root robot on the simulator. So before we hop in and we are coding it, I want you to be familiar with all of the different inputs and outputs that are within the root robot. So on the top here, there's a little yellow nose. This is the power button for the robot. And so when I turn it on here, it will make a little jingle and it will turn on the robot. The eyes are actually light sensors in and of themselves. And so you can code something based on the amount of light. You could code the robot to move, for example. In the center strip here, these are LED lights. So you could code different lights to display, you could code them to flash on and off. These 4 panels are touch sensors. I think that's a pretty special block, and that we at SAM Labs, I guess the proximity sensor would be closest to the touch sensor. But students can kind of touch the front panel and make the robot turn right, for example, or touch the back panel and make the robot move backwards. In the center and with every root robot, there's a marker that comes with it because the drawing functionality is phenomenal with the root robots. And so the marker will fit in there. And then on the front, there are these bump sensors, right? So they're kind of like a mouse. And when you click the mouse, right, you can hear the click sound. And so students could code it that way, or these can be useful when they're driving. It will stop if it like bumps into a wall, for example. Below it and within the robot, here are wheels and there are motors built in. And then there's also a speaker as well as an accelerometer in the back of the robot. So there's a lot of different inputs and outputs within this root robot, which again is a perfect liaison to SAM Labs and all the inputs and outputs kids are using throughout the SAM Labs lessons. The root robot has really everything included in one piece of technology. So let's go ahead and get into our code alongs and exploring SAM root. So you all have access to SAM Studio. So if you would go with me to SAM Studio, you may have noticed that there is some new branding as well as some new features within SAM Studio we just launched, and we're very excited for our 2025 back to school season here. On the left-hand side, you will see the Content Hub, your interactive lessons, your projects, which I'm on right now, and that's the default when you and the students sign in. And then we did add this create option to the side menu where you can actually click and create. It's kind of a shortcut into creating a new project, and it will save in your projects tab. And you can also go back to the main menu by clicking the back arrow. So this is new. We just kind of wanted to limit the amount of clicks in the experience as you and your students are using SAM Studio. And then you'll see your classes or your schools down here with all of your rostering of your students. And lastly, we've also added a direct help feature that links to either the resource hub that my team has built out, right, with all the tutorial videos and implementation and pairing guides. We have our FAQs page directly with common questions that come up, and then a direct email to our customer support technician. Okay, so we're really excited about this all. That's a quick overview of some of the new features. Let's go up to create and let's go into SAM root. Has anyone explored this yet? No, okay. Awesome. So this is part of your experience with your SAM Labs access. You will now have access to SAM root. In the platform here, similar to kind of our content hub, what you'll have are these pre-slugged sections with different activities and lessons already included. And that's something I love about the Root product line is that, the activities, you don't necessarily need to spend a ton of time creating them step by step with students. If they wanted to open up this Draw Unicorn code and click on it, the code is already complete for them. Now, the value with the step-by-step building that comes with the lessons, right, in the Content Hub. But these activities are, kind of just plug and play or pair your Root robot and watch it go because the codes are already complete for the students and for you when you're looking through these lessons. So basically, when you open up a project, here I'm showing you the unicorn code. This code is specifically built in level 2. So down here you can see we're toggled to level 2, which is the block-based coding platform. And you can toggle between the different tabs and categories of the block-based platform by clicking on the different categories below. And everything is color-coded so that students can think about, okay, if I'm adding a logic block to my code or I need to build out some conditional statement, I'm going to go to this section and now I can go and look at my code and see any logic in my code because that's going to be orange. Okay. So when you're running the simulation, you can see that the Root robot is over here on the right. And if you click play, it will go ahead and run the system that is built on the left-hand side here. So while we're letting this this robot draw the unicorn, this is quite a long code, right, with a lot of detail. But I did want to, oh no, I did want to highlight specifically, go back here. I did want to highlight specifically that as it's going through every line of code, something I really love is it's going to highlight that line of code. So kids can start to understand that that instruction in their code is controlling the hardware in a certain way. Now, the Root robot will kind of continue on and draw this unicorn, but in the meantime, let's say I wanted to see what this code looked like in level 3. Another really amazing feature of the Root robot is that you can convert between all the coding levels while the Root robot is running, and students don't need to create a new project to convert the code for their robot. So now, if you were talking with some students who might be ready to explore some script-based coding, they can now see what those lines of code look like in Python as students are watching the robot actually draw the unicorn, right? So we can go back here to block-based code and back and forth. So I'm going to stop this for right now by clicking the stop button, but you can kind of see the unicorn shape. Obviously, it would continue until everything is complete. But I love showing this example because it shows the detail of the drawing that can be done with the Root robot. Lastly, I would like to show you level 1, right? So this is where our K-5 kiddos are likely going to be. 4th and 5th start into some Blockly or level 2 block-based coding. And for the level 1 platform, again, it converted this already. It's one line of code because it's one instruction. That is, we're controlling the different directions of the robot in this case to actually draw the unicorn. So down here, you'll have the main categories of events, commands, setters, and then flow control. And within each of these categories, there's actually settings to control, is it 180 degrees? Is it 360 degrees? And so some of those math concepts do come into play when students are looking at some of the instructions for their Root robot and the settings. So, within SAM space, we have a lot of different behaviors that are giving those specific instructions. In SAM Root, you're going to be using these main blocks and then actually going in and adjusting the settings within these blocks themselves. When you want to get rid of a block, you're going to click and drag and drop it into the trash can. And you can also use the back arrow and the forward arrow to undo in SAM Root as well. So that's kind of a crash course in the platform. Are there any questions before we go through and build a code together? Yeah, it's pretty awesome. Totally. Um, okay, cool. So very quickly, I'll show you up here. Once you know the root robot, if you do have the physical ones, pairing is pretty straightforward, where you'll click connect the robot, and you can actually name each root robot as well, which is really useful. So you can have root one, root two, root three. And then students, you can label the robot itself so students know when they're pairing to pair root one or two, whichever one they have. Um, and then you do have the option once you have the physical robot to keep the simulation going or not. So for the purposes of this training, we'll use the simulation since you all don't have the physical one. Um, and we're going to go into just a quick exploration to get our root robot moving. So we're going to create a new project together in a second, and we're going to give the instruction to the root that when we click the play button, we want the robot to move forwards, um, based on, just the instruction of the play button. So when you're creating a new project, you can click this plus button. So if you wanted to start from scratch, you could also do that if you didn't want to do any of the pre-slugged activities. And we're going to, this is already the first block of every code when kids start a project, but we're now going to do the instruction to move our robot forward. So it's this first block. Go ahead and click and drag that in. You'll hear it snaps in. And now if you go ahead and give the instruction of clicking the play button, you'll see that the root robot moves forward. Okay, pretty straightforward, but let's say we wanted the root robot to move forward a little bit longer, right? We wanted to go a little bit further. So if you click on that block, we can now decrease the distance. Well, it sounds like it was at the max. In this case, it's at 16. So maybe we want it to go a little bit shorter to 12. And now we click out of it and click play, and it goes 12 centimeters specifically. And so in real life, the robot would only move 12 centimeters. So that detail is what allows those codes to build like a unicorn, for example, right? Is that amount of detail and instruction. So pretty straightforward with dragging and dropping. Let's hop into our first code along for drawing a shape. Um, I created a one pager with these instructions. We'll drop it in the chat if you're somebody who wants that extra visual. There you go. And then I'm also going to open it up here. So we're going to draw a triangle specifically with the root robot. The steps for a triangle are pretty straightforward. So we're going to start with the play button, and then we're going to drag and drop the marker, a loop, moving the root robot forwards and to the right. And this loop is going to actually give the instruction to do that 3 times, because how many sides are there to a triangle? There are 3 sides. So this is an example of one of the lower L lessons in the math tie-in. So I'm going to get rid of this one. Okay. And the first thing we're going to tell our root robot to do is to put our marker down onto our mat, right? So you can imagine on the whiteboard, that's happening up here as a teacher with the root pro. And then the next instruction is the loop. So go ahead and drag that into your, after the marker. And we're going to adjust the loop. So if you click on the 2, you can move this little bar. You can do infinite loops all the way up to 9. But for us in our triangle, we're just going to do 3. and then click out. And now the instructions that we want to loop 3 times is going to go in the middle of this loop. And that is that we want our robot to move forwards and move to the right, move forwards to the right, move forwards to the right. So we're going to click and drag. And then the turn right, you can also see there's a little text box that appears. And that's it. So I'd have students narrate this before they build. What do you think your root robot's going to do? Let's make a hypothesis before we run the system. Once you do that, you can click play. And let's see what our root robot does. Okay, so it did not create a triangle, right? So this would be an example of like, can you debug it? Can you go through what shape does this look like? What shape is this going to turn into, right? And to make those connections, which kind of leads us into the challenge part of this, which is it's actually going to become a square. And so this is just an example of like we're taking an activity and extending how the code would be adjusted. So now if you add the loop to go 4 times, you can have a really great discussion with your students about how, this is what angle is this root robot drawing in, right? What do you notice about that that's making this square shape? Um, Any questions on drawing the shapes? I'll show you the triangle in just a second. Any questions on that? Cool. So let's go ahead here. Let's name the project. So you have your first project and click save. And then if you click those 4 squares in the top left-hand corner, it will bring you back to the main page. Let's see. Okay, here's the triangle. And there's our root robot. So specifically, and this is on an infinite loop, so I'm going to stop it or otherwise it's going to keep running forever and ever. I want to throw this to you all and get you all thinking this evening. I know it's late for some of us. What block do you think we need to adjust in order to make this a triangle shape rather than a square? Okay, let's see this chat. The turn. Yeah, exactly. So specifically, it's these turns. So this is moving forward 16, and this is moving forward 120. Okay, what would it be if it was a square? What would this turn right need to be set to? Yep, exactly. Thanks, Carrie. It would be 90 degrees, right? So that's like a perfect example of how the codes will say the same, but what's changing is the settings of each of these blocks. And now you have a triangle. Ta-da. So that's our drawing code. Um, I love that code because it students love it, right? And the drawing feature is phenomenal. There's a lot you can do with it. The other code alongs that we're going to be doing are to showcase some of the other features. So let's hop into the sound output of the Root Robot, right? It has a microphone, and we're gonna actually start with a code and finish the Twinkle Twinkle Little Star code. I want to highlight this in Sam Root because I think it's a phenomenal feature. It's now on our roadmap for Sam Labs, but Sam Root has the ability for you to share a specific link and code with your students so that they could see the project and complete a project. And so that's what I'm going to share with you here. So if you would copy this link, put it in the chat. Open up this Twinkle Twinkle Little Star system. We're going to go through completing it. Okay, so it's started for everybody. And specifically with the root robot, you can code the different notes of the song. And when you click play, you should hear it on your computer. So I'll let you go ahead and take a second to play that and see where it leaves off. Okay, did everybody get a chance to hear the little tune? Okay, so now we need to continue the song, right? This could be a challenge that you give your students. So we're going to start by dragging the play note block after the re, and the default is do, but from here, students, if when you click on the different notes, they can actually hear the sound and hear the note itself. And so, oh, bummer, Florencia, sorry to hear that. Well, you would hear the sound of all of the different notes, as well as in these. I mean, this is testing my music knowledge here, everybody. The different types of notes that students are could be using to complete the song. And they can also translate between these two um, keys. Is that the right word? This is I was not a music teacher, y'all, so bear with me. But this is a great example of how these lessons could really teach all of us a little bit more about music. So, you know, the challenge could be for kids to go through. I'll give you a couple of minutes to play around with it and see if you can complete a couple more notes to the Twinkle Twinkle Little Star. And if you did want to peek ahead, it is in the step by step if you wanted to follow the step by step specifically. Okay, what do we think? Anybody able to get a couple more notes to their Twinkle Twinkle Little Star song? It's kind of tough, Florencia, whenever you don't have the sound, and you have to be a music pro and know what each note would actually sound like. Um, Anyways, I do think while you're all finishing up, I think that like codes like this, you know, if you didn't have every student group didn't have a root robot, is still fun because they can like hear like the code that they're building is actually working from their computer as well. So not as dependent on the root robot moving around the classroom and drawing like the shape code. So the rest of it's here. I also will point out that in SamRoot, there is a whole section down below with music. Okay, so when we're talking about the arts and those integration points that I mentioned, there is the whole row, row, row your boat here. if you wanted to open it up and simply play it. But we turned this into a challenge by giving a first portion and then removing the rest of it for students, right? And you could do that with any of these songs, um, or you could have students just open them up and test it out as is. So our last code along together is actually from our SEL section. And so I mentioned this briefly, right? I think Root does a phenomenal job of integrating some social emotional learning activities with the robot. And one of that is actually a dance challenge. So students get to 10 minutes with their robot, code their robot to dance. Okay, and their character to dance. And then you can have everybody bring up their codes, run the codes, and you can have a little dance off with all of the robots. Super cool. What a great movement break. The kids could also have a dance off right before moving on into any instruction. So that's just a simple activity. Now, similarly to the project sharing, I do have a pretty robust robot dance here. So I'm going to drop this link into the chat for you all. You can go ahead and open it up. So this might be your exemplar for your students on what the robot's going to do. Obviously, before running the code, I would encourage you and I would encourage your students to narrate it, to think through what is going to happen. What do we envision our robots going to dance like when we run this code? So if we start with the first line of code, when we click on the front panel of our robot, it's going to light up and it's going to move in a 360-degree circle. This color specifically is going to be yellow. Great. When we, let's see what this instruction is. When we click on the front panel, it's going to light up. It's going to be on a loop of moving to the left 45 degrees and then to the right 45 degrees. And it's going to repeat that. It's also going to light up. And then the last move is an option for a loop that's moving the robot forward 16 centimeters 2 times around, and then it will stop. Right. So just kind of encouraging them, if you are sharing these activities, to think through what's going to happen so that they're thinking through the code of what is actually built or what they're building. So if we want to go ahead and click play, let's see what happens. So you'll notice that when you click play, the robot's not moving yet. And that's because you do need to click the panel in order to trigger the instructions, right? So that's the input for the robot to actually start its dance. And there is one dance move. So that is this line of code here, right? And you saw it kind of light up. So if we click it again, it's gonna do that 6 repeat, left, right. Um, and there you have it. So, whoops, where is my step-by-step here? This is what's already built for the kiddos, but the final pieces are to add on to this code to make it more specific. So for each line of code to be triggered by a different input and to have a different color output as well. You can see here in the step-by-step, like you could add different moves to make a jig for the robot. You could keep it the same, right? This is kind of a choose your own adventure. But I'll give you all a couple of minutes to experiment with clicking on the blocks to change the colors specifically, or clicking on the inputs to trigger, like, okay, when I click the top left panel, then it's going to trigger this line of the dance code for my robot. Yes, good question, Florencia. When you share a code, it becomes a new student project. So it's not changing your main project. but they're copying it to their library and they're able to edit it from there. So I'm going to specifically say when I touch the different panels, I'm going to turn off some of these other panels so that the front right is this dance move. The front left is this dance move forwards. There we go. And then maybe the back right is the stance move. And if you zoom in, you can use either this magnifier. You could also use that. There's some nice features on like recentering if your robot goes off the screen. You can click and drag this if you wanted to see a different view. I typically keep it the bird's eye view here, and then I'll zoom in with my mouse pad as well to see the different colors of my robot in this dance off. There he goes. Back and forth. You can only run one line of code and one instruction at one time. That's something for kids to explore and to experiment with. Questions, thoughts? Do we all have dancing root robots? That rhymed. If you wanted to differentiate, obviously, kids can work in the block-based platform. So maybe you have kids who are new and are, the level one platform and picture-based is where they're at. Maybe you have kids who are more advanced and are ready to go in the block-based with these instructions specifically. Or maybe you just want them to translate it to start to see what the code would look like in block-based. They can also do that and test it out. Nice. Florencia added music. Love that. Yeah, add a little tune. Put on a song. Let the robots go. A lot of creative and fun ways to integrate the coding. Obviously, the critical thinking skills and also those creativity skills into the classroom. So that concludes our code alongs. Please feel free to use these and you can print them out if you would like. The purpose of them is to take these activities that are complete in SAMRoot, and they'll be complete for students as well, but to kind of turn them into some different challenges and showcase how you all can take whatever is already in there and turn them into some simple activities to introduce students to the Root robot. Let's see. Okay. So going back to my slide deck here, before we wrap up with the survey, I did want to go through, upon completion of the survey, you all are going to get a root light and you're going to get a chance to try this with your students. The root light that you're getting for participating in this workshop is the Root Light and Coding at Sea bundle. And basically this Coding at Sea bundle is a specific mat that comes with a Root robot. So every Root Light robot comes with a foldable whiteboard, we call it. And so students can put that out on a flat, hard surface, desk, table, floor, And then they can use the marker that also comes with the Root robot for all the drawing features of the Root robot. Okay. So this mat is actually themed. Uh, it's kind of pirate themed. It comes with some stickers that are pirate themed for the kiddos, or they could decorate the robot that way. And it also comes with a set of lessons for you all to try. Now, the lessons are in a different platform, and that's not available in SamRoot. Like SamRoot has some of these starter activities and allows you to use the simulation, but the lessons come on a separate subscription. But we wanted to give you all an opportunity to try these lessons. And so there's about 10 lessons that will also be sending out to you that go through utilizing your Sam Lite and the different platforms. So for example, cardinal directions to get your root robot from different points on the island with the pirate theme. So it's super cute, super creative. There's a whole kind of landmark game and matching activity, as well as a logic mapping for conditional statements specifically. Okay. So that is what you can look forward to. Are there any questions on the features of the Root robot, the hardware, SamRoot itself? Any questions I can answer?